Welcome to the overview and introduction to APTI 419B, Preparation of Fine Particle Emission Inventories. This is the seventh of several modules that introduce the APTI Classroom Course 419B. This module introduces the Fugitive Dust Inventory. In this session, we'll overview fugitive dust terminology. We'll introduce and overview four categories of fugitive dust emissions, including agricultural tilling, unpaved roads, paved roads, and road and building construction. Finally, we'll discuss the removal of dust emissions by vegetation and structures near the surface. Fugitive dust is particles of crustal material emitted by various open-air operations that disturb or crush the soil. Fugitive emissions don't pass through a stack or a vent. In contrast, fugitive process emissions are generated by open industrial operations. The source could be located outside, but often is within a building, with emissions escaping through a vent, windows, or a roof monitor. There are other fugitive dust categories that are not discussed here. For example, sandblasting, demolition and debris removal, power blowing of leaves, edging, and grass clippings, mining and quarrying operations, and windblown dust. Note that a windblown dust model is currently being jointly developed by NOAA and the EPA, and this model appears promising. The fugitive dust categories in this table comprise about 1/3 of all primary PM 2.5 emissions in the U.S. for 2005. These emissions don't have a proportional impact on air quality. The largest category of fugitive dust emissions is unpaved roads, followed by agricultural crop tilling. What affects emissions from tilling operations? The number of tilling passes and the silt content of the surface soil and the acres tilled. How can tilling emissions be reduced? First, by making fewer tilling passes and also by tilling at times when the soil is somewhat moist. Low or no-till farming methods are also a popular and effective method of reducing these emissions. What affects emissions from unpaved roads? Well, vehicle miles traveled and vehicle speed affect emissions. Also, the moisture and silt content of the road surface material is important. What reduces the emissions from unpaved roads? We can reduce traffic or the speed of the vehicles traveling on the roads. We can water or pave or chemically stabilize the road surface. Paved roads are a little different. The vehicle mile traveled and vehicle weight are important, and the silt loading on the road surface is important. Also, rainfall suppresses dust emissions from paved road surfaces and washes the roads clean on occasion. How do we reduce paved road surface emissions? By preventing silt buildup on road surfaces or by rapid cleanup of dusty road surfaces. Construction emissions are a little different. They are affected by the acres disturbed by construction, by surface material moisture, and by surface material silt content. We can reduce construction emissions by reducing the speed of vehicles and equipment that are traveling in these construction sites and by watering or chemically stabilizing road surfaces. Where can acres disturbed data be found? Acres disturbed data is sometimes hard to find, so surrogates are used for acres disturbed. For residential, the surrogate is total housing starts data. For commercial, it's the dollar amount of construction by county. And for highway construction, it's the dollar amount of road construction by county by road type. Then default factors are used to convert the surrogates to acres disturbed. Adjustments can be made to account for local practices. Now let's switch gears and discuss the transport of fugitive dust emissions. Recall I said earlier that the impact of the fugitive dust emissions on air quality was not proportional to the emissions. The impacts are much less. Fugitive dust is the principal source of crustal materials in the ambient air. Crustal material is a small part of ambient PM 2.5, much lower than estimated emissions would suggest. This is because the inventory doesn't account for removal of dust particles by surrounding surface vegetation and structures. To better describe the dust transport process, two new terms have been coined. Capture fraction, which is the portion of dust emissions removed by nearby surface cover, and transport fraction, the portion of the emissions that are transported from the source area. These sum to 1 or 100%. In other words, the capture fraction plus the transport fraction equals 1 or 100%. This chart shows that the capture fraction increases with the density of the surface cover. Capture fraction is very high for leafy vegetation and lowest for barren or partly scrubby land. A few notes on transport and capture fractions. First, windbreaks are an example of a dust capture mechanism that have been tried and true and used for decades. Also, note that the transport and capture fraction concept has only been implemented for use in grid models. Gaussian models would require a different approach. More information is available in the emissions processing section of the CHIEF website. The classroom course will include more details on the calculations and equations that we've discussed here. It will include data sources and calculation examples and further explanation of the dust transport and capture fractions. Thanks for your interest in fugitive dust.